Hi everyone, so today we're going to be setting up a structured chat agent in Langchain. This agent, we're going to give it access to two tools. One is the vision tool.
Please wait while I access the camera. You are showing a notebook with a drawing of a grumpy looking cartoon mouse and the word brain written below it.
Tool, and the other is the screenshot tool.
Please wait while I take a screenshot of your screen. I have taken a screenshot of your screen. It shows a macOS computer with a code editor open to a file named requirements.txt. File lists Python libraries like Pillow, Langchain, and others. Below the code editor, a terminal window displays a conversation between you and a language model. You've asked it to look at your screen, and it's responded by identifying a Python script and Langchain usage. You then asked for a detailed description, which is what it's currently working on. The screenshot also reveals other windows like a file explorer, a timeline, and various application icons. Overall, it captures you interacting with a language model through a Python script, demonstrating the model's ability to understand requests and respond helpfully. It also highlights how language models can interact with the real world using tools like screen capture.
If you've noticed, these two tools would actually produce images, so definitely for the agents, which it will be tied to, this agent is going to be based off a multimodal large language model, just to enable it analyze and describe the image in detail. So for the vision tool, we are going to be using OpenCV. This would give us access to the webcam and enable us to take a snapshot of whatever is in front of the webcam. And for the screenshot tool, we're going to be using the Pillow library. I think it's PIL for short. And we'll be using image grab class in it. So that's what we'll be using. So this is a basic rundown of how the system is going to work, and we are going to set it up right now. So let's jump right into the code. So if you take a look at our requirements.txt, as you can see, Pillow, you can see Langchain, OpenAI. We're going to import the chat OpenAI from here, but I don't think we need this anymore because we won't be using this with our local model. But we are going to be using this explicitly, the Langchain Google Vertex AI. Now, the reason why we're actually using this one and not the, I think there's another one for Google chat models, I think so. But we're going to be using Vertex AI. And for you to be able to set it up, you need this credentials.json. It's named something else, like it's once you download it, it will be named something else, but I just renamed the file to of mine to google-credentials.json. And to get this file, you can go over to your IAM and admin. Yeah, I think that's where you need to go to. Or you could just search service accounts on your Google console, your Google Cloud console, and make sure your project is actually selected. And once you search for service accounts, you can click on the service account that you want to get a key for. Or I think it's usually one service account you see there that's already set up, but if there's multiple, you just choose any of them that you want to actually use, and you go over to the key tab. You see the details, permissions, and then you see keys, metrics, and logs. What you need to click on is the keys tab. And once you click there, you're going to see the add key button, and make sure you create a new key. Once you create a new key, it will ask you if you want JSON key or if you want a P12 key. So you want to go for the JSON key because we'll need it here to enable us. Because if you look over here, I set the environment variable for Google application credentials to Google credentials.json, this file over here. So once you've created it, it will automatically download. It will be automatically downloaded to your file browser, your file explorer, or your Finder if you're using a MacBook. And once you have that, you can put it in your project directory and you're good to go. And that's basically what you need. And for now, in the main.py, I'm going to take this off. So we're going to be using Chat Vertex AI, and as you can see, we imported it from Langchain Google Vertex AI module, and That's all good. And if you look down here, you're going to see that I have here's a Piper. This is a text to speech engine, which I set up on another video, but I'm going to link it in the description. And basically, I just want it to be more intuitive. Like you saw in the demo earlier, it actually had a voice, and that was the voice I actually used for this particular video. And you can choose to set it up by going to the video, which I would link in the description, or you can just keep it, you can just comment it out. And you can either pass this here, or you can actually add a callback. You can call the callbacks parameter and add a callback for this agent executor, and maybe when on chain ends, it should just voice this instead of doing this here. So it's up to you. You have so many options, and the two tools, like I said, the vision tool and the screenshot tool. Now if we go over to the vision tool, as you can see, this is class, and this is the name, and this is the description. Use full tool to take a snapshot. Use this tool to access the user's webcam. Use this tool when asked to take a look at something and no context was provided. Formats as. So if you look right here, what I'm trying to do is I'm trying to tell the LLM to format the input. When you're actually using this tool, format the action input as this dictionary. Basically, it should pass in the query and the wait message, because sometimes the LLM seems to gloss over the wait message and just ignore it completely and only pass in the query. But I want it to pass in the wait message no matter what actually happens. And I am doing this to just reinforce that, because just in case I choose to use a smaller large language model, I want it to always do that, because sometimes the large language model also gloss over it. So that's just it. So let's go over to the arguments. You can see the vision input, query, and wait message. And if you look at the description of the wait message, you'll see address the user politely and ask the user to hold on while you access the webcam. It's that simple. But for the query, I wanted it to use something static, so it would always use this as the query every single time. I told you use this as a query. Give a detailed description of this image as detailed as possible, because I want it to give a detailed description of what it sees. That's the reason why you tell it to take a look, or that's the reason why you tell it to do whatever. You can modify this however you actually want, but for this particular video, it's just simple, just telling the LLM to take a look at the object in front of your webcam or on your screen. So you can actually modify it however you want. So if you look at the run function, as you can see, I called Piper TTS, which would actually voice the wait message, or you can actually print it. If you're not using Piper TTS, you can just comment this out, and the image path is captured. Now let's look at the capture function. It's a very simple function that's using OpenCV. As you can see, it selects the default camera. It selects the default camera, and then it checks if the camera is opened. If it's not, it shows this error. If it is, it prints this message, camera opened successfully. I added this right here to give it a little bit of delay before it can actually capture any frames, because if I don't actually do that on my MacBook, I get a blank screen. So that's just it, basically. So it checks if it's grabbed the frame. If it didn't, shows this. If it did, you save it as an image, snapshot.jpg, to the images folder over here. It's that simple, and you write it, and once it's done, it release the camera and return the image path, because this is what we need. Now if we go back to the run function, as you can see the image path is this, then it sends it to the analyze image function. Now this is the function that talks with the multimodal large language model, as you can see. So basically you can use the multimodal large language model here alone and use a normal LLM here. So in the main.py, you can actually use just a normal LLM that does not have vision to call the functions or to call the tools or whatever. So it's definitely up to you. You can play with this however you want. So what else? So if we scroll down, the async, at the end of the day, it analyzes the image. It takes in the query as text. It takes this in as image URL, and we'll pass the image here, and it invokes passing the message to the LLM, and we return the response, the content response, or the response contents, whatever. And the async is basically awaiting the normal run. So for the screenshot input, it's basically the same thing. We also have a wait message to tell the user to hold on while you screenshot the active window. And we have the same query. They are basically alike, and we also reinforce the input format, the action input format, and we pass this in here. So everything looks good. And for the screenshot tool, we're actually using the image grab class, and we're calling the grab function, and we'll screenshot the active window, and now we're going to save it and we'll return it. So we are returning the image path, and it's basically the same thing we are doing in the vision tool capture function, as you can see. And let's go back to the screenshot tool run function. As you can see, we are actually getting the image path from the capture function, and we're sending it over to the analyze image function. So it's that simple. If you look here, we are not actually returning direct. So at the end of the day, whatever the LLM gets here and the main.py, it would just either summarize it or it will just present it as is to you. So it's definitely up to you. You can actually ask it to summarize it if you want. You can add it among the prompts. So it's definitely up to you. So now let's test it. So let's open the terminal and make sure you have virtual env installed or conda. It depends on your preference, whatever you want to use to set this up. It's definitely up to you. So now let's run the code. So I'm going to ask you to take a look, and I'm going to show you this drawing in my hand. I just want to see how powerful Gemini 1.5 Pro is, if it can actually recognize drawings.
I see a white notepad with a cartoon brain drawn on it. The brain looks angry, and the word brain is written below it. The notepad is being held by a person's thumb and fingers. The background is a plain white wall.
If we go to the images folder, we can find our snapshot.jpg, and as you can see, it works perfectly. Now let's try out the screenshot tool. Let's tell it to take a look at our screen and see what happens.
Please hold on while I take a screenshot of your screen. I have analyzed the screenshot and provided a summary of the information. Based on this information, here are some potential next steps you could take. Asterisk address the warnings or errors in your code. Asterisk provide further instructions to the language model regarding the image analysis. Asterisk respond to the notification on your Messages app. Please let me know if you have any other questions or instructions.
So now let's look at what it actually gave us an observation. And as you can see, it gave us the user is using a Python development environment in VS Code. And you're going to see it's called out the Python packages we are actually using, which is really, really cool. And what it did is that it actually summarized it, but you can actually just ask it to return it directly. Like every tool has this return direct parameter where you can just set it to true and it will end up returning it directly. So that's going to be it for this video, and thank you for watching. And if you like this content, make sure you do like, subscribe, and share. Have a lovely day.